All right, so I just have this laid out as you're reading through these problems because you are setting up the equations. So as you read through it, I want you thinking about what your variables would represent, whether you want to use X, Y, Z for all of them or whatever you want to use, but you should have 3 unknowns in the problem. There should be 3 quantities that represent your 3 variables. So think about what those are first. Then once you know what your variables are, what it is you're trying to find, you can go back through to write your 3 equations. So 3 variables, you should have 3 equations, and then go through the process to solve for the 3 variables. So it says Ms. Garza invested $50,000 in 3 different accounts. She invested 3 times as much money in an account that paid 8% interest than an account that paid 10% interest. The third account earned 12% interest. If she earned a total of $5,160 in interest in a year, how much did she invest in each account? So I'm just going to use X, Y, Z as my variables. But I need to know, before I can make sense of putting equations together, I need to know what my variables are representing. So what are the 3 quantities in this problem that we're looking for, or how would we define what X, Y, and Z would represent? That has to do with it. So there's 3 different percents of interest. Liam? 1 for each account. So there's 3 different accounts. Ultimately, we are looking for how much she invested in each account. So there's 3 different accounts. The difference in the accounts is how much interest each of them has. So I am going to label this, it's the amount she invested. So I'm going to put for X amount invested at, and the 3 different percents are 8%, 10%, and 12%. So I'll do X as the 8%. And then Y would be the amount invested at 10%, and Z the amount invested at 12%. Okay, so now I can go back through and I need to be able to put together 3 separate equations. So starting out, it says Ms. Garza invested $50,000 in 3 different accounts. I can stop there. Anybody know an equation using X, Y, and Z that I could write just off of that first sentence, Braxton? Yes, so since these are all amounts invested, and in total she invested 50,000, X plus Y plus Z should equal $50,000. Then it says she invested 3 times as much money in an account that paid 8% interest than an account that paid 10%. So if you look at this sentence, it's only talking about 2 of the 3 accounts. So not all 3 of your equations have to have all 3 variables. It's only talking about the account that paid 8% interest, which is our X, and then the account that paid 10% interest, which is our Y. So she invested 3 times as much money in X than she did in Y. Anyone have an idea of what that equation would be? I'll let you think about it for a few seconds. What? 3x plus y? Cool. You're on the right track. We need an equals in there, though. Isaac? Close. So if I had, I'm going to write that down, 3x equals y. Because this type of sentence, this statement is tricky. So if she invested 3 times as much money in account X than she did in account Y, which account, X or Y, has more money invested in it? X should have more in it. So the way it's phrased, because it says 3 times as much money in X, makes you want to think 3X. But really, this should be flipped around. It would be the account X should be 3 times as much as account Y. So she invested 3 times as much money in X as Y. So she'd have to multiply her investment in Y by 3 to get what she invested in X. That one was one. And then the next sentence, the third account earned 12% interest. That's just information. If she earned a total of $5,160 in interest in the year, how much did she invest in each account? So here we have another total, but this amount of money is an amount of interest. So we are going to have an equation that equals 5,160. But since the amount of money is representing the interest earned, we do have to take into consideration in this equation the percents of interest. So it would be 8% of the amount invested here. So 8% of X. So I would have as a percent, that'd be 0.08X plus 10% of Y. So 0.1 or 0.10y plus 12% of z, so 0.12 times z, and that should equal the total amount of interest, so 5,160. Okay, so any questions on those 3 equations? I know this is the tough part, coming up with the equations, and every problem's different. So the next problem you do isn't going to have to do with interest and accounts that deal with money. So just reasoning through the questions on those. Okay, so then it says solve the system. So I have 3 equations. And I want you to think about yesterday, because that overall process, we had those 3 main steps from yesterday. That doesn't change here. So even though we have an equation that only has 2 of our variables, so we just have one equation that's set up differently than we saw yesterday, our overall process doesn't change. So what was our first main step that we had to do yesterday to solve these? What did we do first? Braxton? Yeah, we had to eliminate a variable by doing what? Canceling out. How do we eliminate it from all 3? You pick it from 2. So we have 2 different pairs of equations, and we eliminate a variable. When you have an equation that only has 2 of your variables, like this one, what I'm going to do here is my 2 pairs of equations. I'm going to use equation 2 with both 1 and 3. So I'm going to pair 1 and 2 together and 2 and 3 together. So I'm going to keep equation 2 with both of the other ones. So if I have equations 1 and 2, so x plus y plus z is 50,000, and then x equals 3y. And I'll just write this right away as well. 2 and 3 is my other pair. So you still start out taking 2 different pairs of equations. Your goal is still to eliminate a variable. Yesterday, we used elimination to do that. We used the elimination process to eliminate one of our 3 variables. Here, because one of our equations is already set up nicely for substitution, we're going to use substitution to eliminate a variable. So I am going to, since I know x is equal to 3y, I'm going to substitute 3y in for x into equations 1 and 3. So I'm still eliminating x by doing that. I'm eliminating the x even though I'm not using the elimination process. So when I do that here, I'm going to end up with, in place of x, I'll have 3y plus y plus z equals 50,000, which then I can simplify that. I can just combine the y terms. So I have 4y plus z equals 50,000. So here I have one equation where the x has been eliminated. And then I can do the same thing over here. So I'd have 0.08 times 3y plus 0.10y plus 0.12z is 5,160. Multiplying 0.08 by 3, I'd have 0.24y. And actually, I'm not going to rewrite that whole thing. I'll just do this. I'm going to combine these, the y terms. So I'd have 0.34y plus 0.12z equals 5,160. So here I have another equation where I've eliminated x. One thing though, say, since this equation has decimals in it, say you don't want to deal with decimals, especially if I'm eventually putting these 2 equations together. I don't want to have to deal with decimals. What could I do to this equation to get rid of the decimals? Isaac? I could multiply this whole thing by 100 since these 2 decimals are to the hundredths place. So this then would be 34y plus 12z equals, and this will now be 51,600. Oh no, 516,000. I lied. Adding 2 zeros on the end. Okay, so as long as you multiply everything by the same number, the equation is still true. So you can get rid of the decimals, or if you had fractions, you could get rid of the fractions if you didn't want to have to work with those. You could also keep them. It's not like you would have to do that. So I have 2 equations where I've eliminated x. I used substitution to do it. Now I put these 2 equations together. So I'm going to just bring these over here. So 4y plus z is equal to 50,000, and 34y plus 12z is equal to 516,000. And so now I'm solving this system for y and z. And here again, you can use elimination, you can use substitution, whatever you'd like to use. This one, I'd say, I personally would use elimination. I would eliminate the z. What would I have to do to eliminate z?
Attention staff and students. We are currently on a soft lockdown for a K-9 SNP. Please remain in your classrooms and ignore all bells until the all clear has been announced. Attention staff and students. We are currently on a soft lockdown for a K-9 SNP. Please remain in your classrooms and ignore all bells until the all clear has been announced.
All right, I'm just multiplying that top equation by -12, and then I'm keeping my bottom equation the same. So now by adding my equations together, the z's are eliminated. And I'll have, this will be negative 14y. And then equals negative 84,000. So then if I divide by the negative 14, because now I can solve for y, I get y is equal to 6,000. All right, I now have y. I can go back to one of these two equations here to find z. I'm just going to use this top original equation. So if I replace the y with 6,000, it'd be 4 times 6,000, so 24,000 plus z is equal to 50,000. Subtract the 24,000, meaning z is 26,000. So I'm just keeping track of those. There's 2 of my 3. And then I just have to go back to one of my original 3 equations to find x. And I'm just going to use this one because then I only have to substitute the y in. So now that I know y, I can easily find x. So if x is equal to 3y, that means x is equal to 3 times 6,000, so 18,000. Okay, and then you could certainly make sure, here you want to make sure your answer makes sense. So x, y, and z were all amounts of money. I shouldn't have negative values. That would give me a clue that something's not correct. I could substitute all 3 variables into equation 1 and equation 3. I used equation 2 to find x, so I know x and y, that relationship works, but substitute them into here just to make sure that it works out. And as long as everything makes sense, here just make sure you answer the question then in context. So I don't have to write my answer as an ordered triple for these because x, y, and z actually represent something. So I could say she invested, we're talking about how much money Miss Garza invested. So she invested $18,000 at the 8% interest. That was my x. She invested $6,000 at the 10% interest and $26,000 at the 12% interest. So also putting your answer back in context kind of forces you, hopefully, to make sense of it, to see, since I'm dealing with amounts of money invested, does that really make sense, the answers I got? Any questions there? Okay. Then your